Good afternoon, class. We are looking at practice test number 4 for college algebra, module 4, which covers chapters 7 and 8. We are looking at chapter 8, analytic geometry. So we are looking at chapter 8, analytic geometry. Find an equation of a circle with its center at 1, -2, with the radius 2, graph the circle. So x squared plus y squared equals r squared when it's centered at 0, 0 with the radius r. This is the general formula for a circle. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. So in this case, r is given, the center is given. So basically plug it into this equation. You have x minus 1 quantity squared plus y plus 2 quantity squared equals 4. So we have the center. Now from the center, we are going to go r units, 2 units to the right and left, up and down. That's how we come up with these 4 pairs. Okay, so if I want to go to the right, so one easy way is to come up with 1, -2, and then, as I mentioned, are 2 units to the right. That means you add 2 to 1. You also subtract from it. Now, to go up, you add r units to -2, which makes it 0, and you subtract from it. Those are the 4 points which will help us see the graph. Now you make up a decent circle. This is a rough sketch. Write the equation of a circle in standard form, identify the center and the radius, graph the circle. Again, everybody remembers these formulas that were discussed. We want to put them in that format. So to do that, we need to do completing this square. We put -4x next to x squared. We put +10y next to y squared, and we move the constant. Now, I hope everybody remembers how we do completing this square. In this case, b is -4 divided by 2 is -2. Square root is +4, which means we need to add 4 to both sides. For this case, b is 10 divided by 2 is 5. Square root is 25. So we need to add 4 because of this one to both sides, 25 because of this one to both sides. And now it is in the standard format that we are comfortable with, centered at 2, -5 with the radius of 6. Again, look at the center. We are going to go r units to the right. That means look at the x. We add 6, we subtract 6. We're going to go r units up and down. So -5, add 6, subtract 6. It gives us those 4 points. So starting from the center, go r units to the right, r units to the left, r units up, r units down, and there you have it. We do the drawing, and practically we are done. We want to graph the ellipse by finding its center and vertices. So here's the definition of a ellipse was that it's a set of points whose sum of distances from 2 fixed points called foci, focus 1, focus 2 is fixed. And so PF1 plus PF2 is fixed. And this is a comma 0, this is minus a comma 0, 0 minus b, 0 b. If the center is at 0, 0, we have the following equation: x squared over a squared plus y squared over b squared equals 1. If it's centered at something else, let's say h and k, we put x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. What I want to explain is about this, which is ultimately using the concept similar to Pythagorean theorem. So the largest one is always by itself. In this case, because it is elongated along the x-axis, a is larger than b. Therefore, b squared plus c squared is a squared. B is this distance, and c is the distance from the center to the focus. If it's elongated along the y-axis, then a squared and b squared interchange. In this case, a is square root of 25, which is 5. B is square root of 16, which is 4, centered at 0, 0. Because a is larger, it's elongated along the x-axis. So you start from 5 and negative 5. So 5, 0, negative 5, 0, and the top is 0, 4, 0, negative 4. So that's the center. Those are the vertices, and those are co-vertices, if you will, as far as the terminology is concerned. And when we put them together, it's a little bit elongated along the x-axis. Now, in this case, we have an elliptical shape where the center is no longer at 0, 0. So we are using this formula. So the center is at negative 5, positive 7. A is square root of 4, which is 2, and B is square root of 9, which is 3. By the way, this is in standard form. Otherwise, we have to make one side 1 to put it in that format. So we have all of that. Because B is larger than A, that means it's elongated this way. That's the meaning of that. So first and foremost, we come up with the center, which is minus 5, 7. And we're going to go B units up and down, A units to the left and right. So when we have the center minus 5, 7, we go up and down by B units, which happen to be 3 units. So that means you add 3 to 7, you get 10. You subtract from it, you get 4. So those are the vertices. So you write that. And then A units to the right and left. So to the right and left, this negative 5, you add 2 to it and you subtract 2 from it. So you get those. Now, we want foci. Remember, we want the C, and whether we have a squared plus c squared equals b squared or this one, it depends which one is larger. Because b is larger, this is what we have. It's important to understand why we have this. B is larger. So with that being the case, a squared is 4, b squared is 9, so c squared is 5. I hope you realize that from here. C squared is 9 and c squared of 5. It's a positive value. So from the center, you go square root of 5 units. Now, to the right and left or up and down? Well, because again, B is larger, it's along the y-axis. So it's up and down. So we go down and we go up. And the reason we use those approximations for the sake of graph. So we can plot those. Now this is your center. Vertices, co-vertices. Here's the graph, and we have the foci. We can show it somewhere here and there. The graph is given, And we want to come up with the equation in standard form. It's an elliptical shape, elongated again along the y-axis. So we are using this formula, and we need to find the center, the vertices, co-vertices, all of the above. So we can see the center, vertices. Let's write. So first, those are important points. The center is located at -2, 2. -2, 5 is one of them. -2, -1 is another one. So we have those vertices. We have this one and this one co-vertices. As I mentioned, we have the center. And now this distance, which is 3, is B because it's elongated. B is under the Y. So elongated along the y-axis, and that's 3 units. That's B, and this is 2. So A is 2, B is 3. We got just about everything. Let's replace everything. We have the equation x plus 2 quantity squared over 4 plus y minus 2 quantity squared over 9 equals 1. So in this formula, we have h, k, a, b. We found everything. And again, this distance is B. This distance is A. Give the equation of the asymptotes and graph the hyperbolas. X squared over 16 minus y squared over 25 equals 1. Y squared over 25 minus x squared over 16 equals 1. First and foremost, the main difference as far as the equation is concerned, you have a positive for ellipse and negative for hyperbola. So here's what we know. X squared over a squared minus y squared over b squared. If the coefficient of x squared is positive, it opens sideways, okay? And the asymptotes have the equation y equals plus minus b over a times x. A squared plus b squared equals c squared is always the case, because this is looking at the definition that says set of points, okay, whose difference of distances from two fixed points, f1 and f2, is fixed. And the focus happened to be somewhere here, somewhere here. This distance is b, this distance is a, and c is always the largest. Therefore, you don't have to worry about it. In the case of hyperbolas, always a squared plus b squared equals c squared. This is known as fundamental rectangle. So it's helping you graph the asymptotes. If we are dealing with this one, the coefficient of y squared is positive, then it opens up and down. All right. I like to keep the a under x and b under y. Some books, they change that when that changes. If you keep it intact, this formula, which is for the asymptote, will never ever change. It will always be plus minus b over a times x. Therefore, in this case, again, in both cases, the center is at 0, 0. In this case, a is 4, b is 5. Same thing here in this case. So let's write this center at 0, 0. A is 4, b is 5. So for this one, because the coefficient of x squared is positive, then we have the vertices at 4, 0, minus 4, 0. So this is for the first one. And the asymptotes plus minus b over a times x gives us plus minus 5 over 4 times x. So far, they have the same center, the same A, the same B, the same asymptotes. In this case, we have those vertices, and it opens sideways. By the way, we have those as dashed lines, okay, class? Dashed lines. In the second case, so those are dashed lines. The vertices, they open up and down because the coefficient of y squared is positive. Looks like that. And again, dashed line. So what was the purpose of this question? I wanted to show you if we happen to have a hyperbola that they interchange the value for positive and negative x squared. In this case, x squared is positive. In this case, y squared has a positive coefficient. Everything is the same until the last moment that it opens sideways and part B opens up and down. So that's the main thing. So I wanted to make sure that we are comfortable with this concept. Identify the coordinates of the center, the vertices, foci, the equation of asymptotes, and graph. So let's see how that thing is going to play out. Obviously, we have everything that we need here. So the center is given clearly as 1 and 2. A is square root of 9, which is 3. B is square root of 16, which is 4. And it right away, because this has a coefficient which is positive, open side. So A is 3, B equals 4. Now, from the center, we go A units to the right and left. Here's the center, and we say it opens sideways because it has a positive value. So A units to the right of this and to the left of that. Those are the vertices. To find the focus and foci, we use the fact A squared plus B squared equals C squared. And C becomes 5. And we know the center is at 1, 2. Therefore, using this, going 5 units to the right and left, give us the location of foci. So one more time, we calculate this value of C using this formula. We have the center located at 1 and 2. We move 5 units to the right, makes this 1, 6. 5 units to the left, 1 minus 5 makes a negative 4. So we have those. Asymptotes, we use the same formula y is plus minus b over a times x, and we move it by h and k in general. So that's why if you go back to the basic one, which was, again, remember the basic one is 1, y is plus minus b over a times x. So you do the translation, y minus k is plus minus b over a times x minus h. That's the formula. And therefore, you use the fact that k is 2 and h is 1. And you can graph this. Those are 2 lines. Y minus 2 is 4, there's x minus 1. You can solve for y. Okay. Now this is 1 with the positive 4 thirds is 1, and again simplified with the negative 4 thirds is another 1. I'm assuming everybody can simplify this. It's not a big deal. Just as an example, if you go with one of them, so what you're looking at here, four thirds x minus 1 plus 2, that's one of them, and simplify. Let's call it y sub 1. And the second one is minus 4/3. X minus 1 plus 2. You simplify. And now you're ready. The two lines, if you graph them, you end up with those. Those are the vertices we found. This is the center, and that's the graph. So that's a rough sketch as far as this is concerned. Now, what if we are given the hyperbola, the graph, and the missing is the equation in standard form? So the first thing we want to notice, the center is given, vertices given, and it's opening up and down. Okay, so you should recognize we are using this formula in essence. So you find the distance between the center and either here or here, it doesn't matter, those are fixed. Okay, so the center is located at -1, 0. We want to find A and B. Let's look at the vertices. The vertices are located at -1, 3 and -1, -3. Therefore, this distance is 3, or you can find the total distance divided by 2. So this is the distance B we are looking for. This is the distance B we are looking for. If we were to find the focus, we can go C units up and down. Take a look that it is given, right? 3 square root of 2 here, minus 3 square root of 2. So the C is 3 square root of 2. Therefore, we can find the missing A with the fact that A squared plus B squared equals C squared. So A squared plus B squared equals C squared, where B is 3, and this is 3 square root of 2. When you square this, you get 9 times 2, which is 18, class. I hope you realize that. Therefore, subtracting 9 gives you 9. A squared is 9, A is 3. So we found everything. We have the center, we have the equation, and bear in mind that we are using this formula. Also, if we wanted to come up with the asymptotes, we can do that. Remember, this is the formula, and this is the asymptotes. Y minus k, that means y minus 0, because it's just y squared. Plus minus b over a, b over a. B and a are both number 3. Because of that, plus minus 1. We want to look at parabolas, and going back to intermediate algebra, I want to remind you what we did. Y equals ax squared plus bx plus c. That's the standard form. Y equals a times x minus h quantity squared plus k. That's the vertex format. This is for the parabolas that open up and down. When a is positive, opens up. When a is negative, opens down. If we write it as quadratic with respect to y, it becomes a parabola that opens sideways. So x equals ay squared plus by plus c, or a times y minus k quantity squared plus h. Both are representing parabolas that open sideways, when a is positive to the right, when a is negative to the left. So that's what we learned in intermediate algebra. And I want to show you how to use that information. First, the definition of a parabola. A parabola is a collection of all points in the plane that are the same distance from a fixed point called the focus and a fixed line called the directrix. So when we look at this one, if we pick any point P, the distance from this focus is the same as the distance from this line. Now, this line is perpendicular to the line of symmetry, by the way, the axis of symmetry. And the two distances are always fixed, no matter what. If I pick a point here and I drop a perpendicular, to this line and I connect it to the focal point or focus, I get the same distance. In other words, D stands for the distance of F and P. P is some point, F is the focus, is the same as the distance of this point to capital D, which represents the equation of a line directrix. Now, one of the things I want to make a point, the distance between the focus and the center is called the focal distance. We normally use P, sometimes even F. In some texts, they even use A. The reason I don't like to use A because I don't want it to be mixed with this A. So I never use A because we have learned this A in intermediate algebra, which is not the same A. This A that they are writing is focal distance. So I like to stick with P or something like that. Now, take a look at the formulas in intermediate algebra. Take a look at the formulas here or here in this course. They would use y squared equals 4px or y minus k squared equals 4p times x minus h. And that's fine and dandy. Okay, you can use that. But if you don't want to remember new formulas, you don't have to. You can stick with that. Just remember the relationship between A that we have here. This A is this one that I'm writing. I'm writing this A for you. It's 1 over 4p, whatever the p value. And of course, you want to account for it when it's negative. When it opens down, it's negative. Okay. So with that being the case, you can easily stick with the old method and then change it when the time comes. If you take a look at all of this, the reason I want you to understand the concept, because if you want to memorize, it becomes too much. So if it opens to the right, so all you have to do from the vertex, go the focal distance to find the focus. And if you go down, you can find the equation of a directrix, whether it's a vertical line or a horizontal line, it depends how it opens. The last thing I want to look at is what's called lattice rectum. If you draw a line from the focus horizontal to your directrix, the distance from here to here is the same as distance from here to here. From here to here, I mean. Now this is P, I'm going to call it P rather than A, and so is this one. So this distance is, they call it 2A, and I'm going to call it 2P. This distance is 2P. And so is this distance. So if I continue on, this is 2 times 2P or 4P. That's how we come up with that. So 4 times P. So with that in mind, we want to identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry, and the directrix, so on and so forth, graph the parabola. We can do it both ways. We can go back and rewrite it. I will explain it to you at the end, or we can stick with what we have here. So let's see what happens. So when you look at this one, you can compare it to this one, and remember, this is for P. This P is the focal distance. So with that being the case, for P is 4 over 5. So P, or the focal distance, is 1/5 or 0.2. The vertex is located at -4, +2. And if we want to know where the focus is, so basically put that in and then go 0.2 or P units to find the focus. So here's the vertex. By the way, you may recognize that this opens up or down or right or left. Because y has degree 2, it opens sideways. If you take the 4/5 to the other side, becomes times 5/4, which is positive. So it opens to the right. You should know that. In fact, let me write that for you so you see how that works in case, because it's really helpful. This 4/5, I can write it as 5/4 times y minus 2 squared equals, now x plus 4 I'm going to take it to the other side and make it minus 4. I hope you see what I've done. So I'm going from here to here. Because this is degree 2, y has degree 2, it opens to the right or left. Because this is positive, it opens sideways. And that's really the idea. Okay. So vertex is located at negative 4, 2. We are going to move it by 0.2. We get negative 3.8 comma 2. We are adding 0.2 to that. So that is the location of your focus. What about the equation of a line for the directrix? It's the same as this one, but it goes to the left. The vertex now to the left. By how much? By the amount of p, the focal distance. We know the axis of symmetry is y equals 2. By the way, if you recall the axis of symmetry, if it opens up and down, x equals h. If it opens sideways, y equals 2. So that's the axis of symmetry. For the directrix, you look at the vertex and you go to the left of that by p amount, which we found to be 0.2. So negative 4.2. So that's the directrix. And that's the graph. You can, of course, pick up a few points to graph it. Now, this is the lattice rectum, which is equal to 4 times p. Well, we already have 4 times p equals 4/5. Now, what I want to remind you again, I don't like to use a because I use a here. Remember that. Over here, I rather use p. Sometimes they use even f. So if you go from here to here, in a lot of sense, it makes it easier for you to remember what you did in intermediate algebra, in which case, when this is positive, means opens sideways in the case of y squared, therefore to the right. Graph is given. We want to come up with the equation in a standard form. And if we want to go with the standard form we just learned, x squared equals 4py, or x minus h quantity squared is minus 4p times y minus k, if we want to stick with that, because it opens downward. And of course, remember that a is negative, or in this case, you can think of p. So look at the location of a vertex, look at the, which is negative 3, 5. And the focus, it is at negative 319/64. This distance is the focal distance. We are looking at this distance as the focal distance. And that's 1/64 or p. So we can write this now. We have pretty much everything. We have the vertex and we have the value of p. So plug in. Negative 4/1/64 is negative 1/16 times y minus 5. It does the job. Or we can go with y equals a times x minus h quantity squared plus k. Remember, this is intermediate algebra. I want to remind you, if you want to go that route. This is the general form. Because H and K is given, we're going to go with that format. So we're going to replace H and K and we get this one. All we have to do, find A. And because of this focal distance, which we have it, and remember, A must be negative. So 4 times that, and it's negative. So A is 1 over 4p. A is 1 over 4p. So 4 times that and the reciprocal of that. Now replace the A. And there you have it. Now I hope you see you can convert this to from here to here or from here to here. And that's identical. That's the same equation, everybody. So we can go either way. I highly recommend you look at what we did in intermediate algebra and look at what we are doing here. The main thing that you want to pay attention, the distance from the vertex to the focus, it's the focal distance. So this again is the value we call P. Again, since it opens down, A is negative. The distance can't be negative, but that's why we say 1 over minus 4p in essence. Here's the function in standard form, and we want to find the x-intercept, the y-intercept, the vertex, axis of symmetry, graph the function. Now, I call this the vertex format. Sometimes they call this standard form. So I'm going to make sure everybody understands when we mention something what we mean. This is really what I call a vertex format. Some people call this standard. Believe it or not, some people call this one standard. It doesn't matter. It's just a terminology. You want to make sure you know the concept. So with that being the case, what do? Well, we don't have to put it in that form if we are not asked. Since we are asked, I'm going to show you how to do that by putting these two together and factoring out the 2. Now, you complete this square inside. This is your B. B is 2. Divided by 2 is 1. Square it is 1. So you need to add 1 inside, but when you add 1 inside, that means you're adding 2 times 1, and therefore you're going to subtract 2. So pay attention to the fact that when we add 1, since the 2 is outside, we are really adding 2. To undo it, we do minus 2, and now it's in the form that was asked. The vertex is located at -1, +4. There is no x-intercept. And the y-intercept, it's easier to just get it from here. Everything is 0, so becomes 6. By the way, if you set this one equal to 0, you notice that b squared minus 4ac becomes negative. Class b squared minus 4ac is negative. That's why it doesn't have any answer. So we have the y-intercept. And when we look at the vertex at -1, 4, this distance is 1. If we go another 1 right here, we have another point. I hope you see that. Because of the axis of symmetry, we have this point also. Do you see that? So because of the axis of symmetry, we can clearly see this point. And remember, it opens up. The vertex is located at -2, 6, and it opens up. So even with that concept, you don't have any x-intercepts. And that's the rough sketch of the graph. Identify the graph of each equation. Let's quickly do that. If we are dealing with conic sections, when x squared and y squared are both on the same side, because these two are identical, then this is a circle. These two have the same sign, but not identical. It's an ellipse. If you move this, they have opposite signs, therefore it's a hyperbola. So a quick recap. Why is this a circle? Again, you can show it by putting it in standard form, or just a simple case, identical coefficients. Coefficients have the same sign when they're on the same side. Coefficients have opposite signs when they're on the same side. Circle, ellipse, hyperbola. Which way do they open? Because of x squared, it opens up or down. Because it's -2, opens down. Because of x squared, opens up or down. Because of 1, opens up. Because of y squared, opens right or left. Because of 1, opens right. In other words, the thing you probably want to add, in this case, a equals -2. In this case, a equals +1. In this case, a equals +1.